All right, we are live. This is made up of wires. We've been decompiling various parts of Castlevania Symphony of the Night. And that is what we are going to continue to do today. Give me a second while I get set up. All right. Castlevania Symphony of the Night was a game for the PlayStation, originally released on the PlayStation in 1997. It eventually was ported to just about everything. And it's still one of the best Metroidvanias, if not the best Metroidvania. It's definitely one of my favorite. Because it's been ported so many places, we have a lot of examples of what the final binary objects look like in that game. And so the Symphony of the Night Decompilation project is trying to take those binaries, decompile them back into original C code, and be able to rebuild them to exactly what they were when they were released for the PlayStation and for the PSP and Xbox 360, other systems like that. You can find out more about the Symphony of the Night Decomp project by going to SOTN.z.dev. There you'll find progress for several of the different objects that are currently being decompiled. Dracula is the main game program. Richter, Rick.bin, the Richter program. Weapons, which we're going to be working on again today. And various stages. So what we've been doing is looking at weapons, trying to find different weapons that we can go through and decompile. To decompile, we're using a tool called Splat64 to take the object files, split them into different assets, data, functions, and then taking the functions themselves and using decomp.me to decompile them and massage them into the final code that is going to be used. I was going to do something a little harder today than we've been doing. I'll go through some of the stuff that's been happening though. Not a lot has made it into the source tree since yesterday. But there are a few cool things that are pending. There's a lot of code reuse between weapons and stages, and we've been trying to consolidate those into shared files that contain those implementations so that they can be reused without having to re-decompile throughout all the stages. So this PR by Biz Murphy is doing just that. It's taking a significant amount of code for collecting items and splitting that out into shared files. And what that allows is dropping a lot of the manually assigned symbol names, dropping a lot of code, in many cases just wholesale getting rid of things, which is awesome. So that's a great PR. Anything that reduces the size of the unique parts of each individual stage makes other stages easier to do in the future. Another area that's being worked on by Sozu is increasing the portability of the code base by making sure that areas like pointers, which can have different sizes depending on the platform that's being targeted, are written in such a way that objects that contain those aren't relying on hard-coded offsets, but rather field names and things like that. So in this particular one, I think there were there was an object that was listed as a bunch of separate mapped variables, if I can find where that change was. Oh, it was this next one. And just making sure that those were correct types that would be portable. Oh, this is the one. This is, so ensuring that when these extensions are being used, this generic extension to an entity is going to use a fixed offset of 7C. These others are using dynamic offsets based on, dynamic in the sense that at compile time, the sizes will be calculated, the offsets will be calculated based on the size of pointers as opposed to static offsets. So that's cool too. Anything to increase portability is fantastic. All right, so today we're going to do something a little more difficult than we have in the past. I have been looking at functions within weapons that are relatively straightforward. They might have some control flow, if-else statements, things like that, but nothing so far has had a jump table, which is marginally more complicated than typical if-else control flow. Usually I write this live, and I can do that again. So I'm going to look for assembly in weapons that hasn't been matched yet. Things with a .s prefix. We're going to list them. We're going to get the size and the name of that file, path to that file. Sort by size. And then we're going to grab the file, or the path, and we're going to look for files that have jump tables. And in order of biggest to smallest, we have this list. So we'll look at this weapon 53. And look at the C file that goes with it. So usually I don't look at these beforehand. This, I wanted to kind of target a specific area, so I did. But this is Masamune and some of the other swords, katana. So we're going to be taking the entity weapon attack function and decompiling that. And we should find some success there. So I'm going to copy that into decomp.me. One of the things about the weapon functions, I didn't realize this until looking at it this morning, was the jump tables are already in line, which makes things much easier than, or at least in this case, maybe it was because it was the first function here. The jump table is right in the same assembly file and not often a separate data file. So let me grab that file name. And I believe this will decompile as is. So in decomp.me, we're going to start a new scratch. I checked for this beforehand as well. I don't see anybody decompiling, at least nobody who's marked the specific function as currently decompiling it. So I hope I'm not stepping on any toes. We're going to choose PlayStation, Castlevania Symphony of the Night preset, and then paste our assembly. The difference between this assembly and others is that we have this section at the top of RO data with a jump table. And the way jump tables work is that the compiler will create a bunch of conditional branches, but those conditional branches all result in an offset into this table. And so you might have a switch, and the switch matches against 3, 12, 5C and hex, things like that. It might seem like they're spread far apart, but the compiler will go through, condense all those down to one of, in this case, 5 cases, and use this table for its offset. So, and then this jump table is used in that code down here somewhere. Oops. Down here. And so this will get set and we'll jump. So let's decompile that and see how close the decompiler gets. And that so far looks pretty good. Looks very similar to the function from yesterday. The same type of, we have blocks that seem to be unnecessary. We have some functions that are probably outside of this condition. And then, of course, we have the switch statement in the middle, which was a result of that jump table. This one's pretty simple. So hopefully we'll have some success here. We're going to do the same things that we normally start with. Getting function signatures that aren't in our context, adding those to the context. This is I'm looking up the signatures for these in the background. I move those into the context because they're not part of what we're decompiling now. They're already, the declarations for those functions are already defined elsewhere. This is going to be a sprite parts array, and I believe this is going to be a weapon animation array. And we can move those into, the weapon animation will need, the sprite parts we won't. I'm going to move both of them into the context and do another decompile. And the reason I do that is to get a cleaner base to start with. I'm going to move back the weapon animation because we'll need that for declaration. It's likely not been provided before. So we are compiling now, which is good. We still have a few other things to get everything in a clean state to start. This standard C hosted in the context is an unnecessary macro that conflicts with one of the default defines. We have string compare, string copy, string length. Memcopy, those are built-ins that GCC provides, but we don't want to use those versions. We want to use ones provided by the PlayStation SDK. We have an issue with missing forward declaration. I should regenerate my context to fix that. That has been fixed in the GitHub repo. And so that leaves the only warning left being the one related to the code we're decompiling. So we'll save. So after getting through the compiler errors and missing declarations, we're already at 78.94%. So there shouldn't be much work to do today. I'm going to go through and do the same cleanup that I normally do, replacing arg0 with the name self, indicating that this is a entity function that's operating as if it were a method on an object for this entity. I'm going to reformat this code first and then go through and fix the player symbols. Okay, there's not a lot left there. And then the next step is to go through and replace these player symbols with struct access into the player macro, which is the first entry into. I know. I really should have. I should have those 4 declarations in my context. Oh, I see what you're saying. Yes. That would be smart as well to put entity weapon attack in the context. This function name is used over and over. And the same thing with actually the first 4 functions in each weapon. They're all named after offsets into a struct that has 4 methods for each weapon. And so all of those could be moved into the context, and every time then I decompile, I would get that for free, which is a good idea. Thanks for the suggestion. Okay, so I'm going to get rid of all these players and go through and fix all those. Fix this first one, which the decompiler misses. So these are going to be using the player field of that extension union and looking at the current animation frame, and same thing here. Likewise, this gplayer unknown. We're going to see a lot of the same ordering things that were there yesterday. Line 54. So changing all those to struct access instead basically gave us 10% for not doing a whole lot, which is nice. I'm going to go through and replace this block. So we have our go-to on line 59. Actually, I'll keep going with the struct access and fix all the G APIs. I went and did this gplayer on the way. We won't need that, and the G hand ID. We'll move into the context. All right. So then going back to this block, we'll take a look at that. We'll move the destroy entity up here. Oh, we need it at the end still, but this one, and then we'll return. That doesn't change the compilation match, but it makes the code easier to read. This is going to end up probably being nicer as an else, and we'll return from this as well. And then we'll see here that some of this code is out of order. The destroy entity in the compiled code is happening before, but it's happening conditionally, and that's because these assignments are happening outside of this block. And so those match as well, and now we're at 93%. So we're going to see some of the same things up here around these values being out of order. Let's go take a look at line 26. In our, so 24 through 26, there's a bunch of these immediate values that are wrong, and that's because these struct values are being set in the wrong order. And so when we reorder those, all the immediate values now match. And so that's matching as appropriate. And a similar thing for the Z priority. Let's see, animation set draw mode. This is the one I always forget what order they go in, so I'll pull one of these up in the background. Palette flag Z priority. Let's draw mode last. Yep. So now those match. So we have some things near the top. That's going to be this params, how this params field is accessed. Let's do a little more cleanup before we get there. There's some temporary variables that probably can go away, and some others that should be renamed. Weapon animation temp S1. We'll call that anim for animation. So we're grabbing a reference to that animation and then assigning the frame start to temp v1. The compiler can do that for us, and we can make this a little more readable and not change our match at all. And then we have this business here where we're grabbing an index from the parameters and using it to get the particular animation. When temporary variables like this are disjoint from where they're used, these statements are typically out of order. Not always, but it's pretty common that they're out of order. In this case, it didn't change anything, but that's fine. The animation index, so an index is being pulled out of the params to determine what animation to use, and I believe that's because this weapon is being used for several different this function is being used for several different weapons in the game. So yeah, comment as you want. Any interaction is great. I'm doing this for myself and for my own edification, but also for educating. So if there's anything that I'm missing, There's a comment in chat about backseat driving. Don't worry. If I don't like what you say, I'll ignore it. All right, so params is kind of a field that's used by different entities for different things. In this case, this particular weapon, it's the katana, the masamune, yasetsuna, and a couple different other weapons. To choose the right animation for each of those weapons and what to draw, it looks like it's using this params field, and specifically the upper 8 bits of that params field. And so we need to extract the bits that are responsible for that index. The decompiler thought this was going to be a unsigned 32-bit integer. I'm pretty sure it's going to be a signed 16-bit integer based on other code and based on the instructions that are there. So we're going to change that to animation index to match what exists elsewhere, and we're going to get rid of this cast and see if that helps or hurts. And we're using that somewhere else. That helped a lot. That actually put everything in place. So kind of going back to that as well, I'm running through this one pretty quickly because it's so similar to the last couple days. This was the decompiler thought, likely because of some of these mask and shift operations, this looks like an unsigned 32-bit value. I'm going to create a variable with that type. But then when the compiler comes through and generates those instructions, we get a lot of things that are not matching. The masks are different. In this case, we're loading a byte value at a specific offset as opposed to accessing that as a 16-bit value. And then we're missing shifts and other things like that. So not only does that change the instructions that are used using 32-bit, or in this case, it wants to use a byte instruction loaded into a 32-bit register. Not only do we generate the wrong instructions for the wrong size type, we also generate a different collection of instructions which pushes down everything else and either adds or removes things that should have been there, which makes the diff between the two look much worse than it is. And so when we correct the type and the correct instructions are being used, everything else falls into place. This can be pretty challenging when those types are wrong, but they're wrong not necessarily at the beginning, maybe in the middle or end, and it can seem really non-obvious why there's instructions towards the beginning that are mismatched. And then you change a type for a variable that's used in like the last quarter of the function, and everything else falls into place. In this case, that's what it was. So this one was very simple. I chose it because of the switch, which introduced a jump table, which is additional data that you need to pull into decomp.me. But really, that switch didn't introduce any complexity. I'm looking to see if there's any reordering here that can be done. There are some magic values here that I'm interested to see what those are. We can look to see if there's analogs elsewhere for those. There's still a warning. We're not done. There's other cleanup that can be done. I like to go through and get rid of superfluous parentheses. And unnecessary casts. We'll also go through and deal with this warning. So this is warning that we have a value that's overflowing this 16-bit field. There is a macro that will mask this. This is for an animation set that's going to exist in the weapon overlay. And likewise, this is a palette that's going to exist in the main game overlay. We have flags here. These are going to be unknown flags for this entity. So we're going to look for... We have macros for those, though, so that they can be found easily. Likewise, draw mode. I believe this is draw mode, tpage 2, and draw mode. No, not mode. Draw tpage 2. And draw tpage 1. All right, so the next thing I'm going to look at is these create entity factory from entity calls. So we're taking the hand ID, shifting it by 12 bits, and then adding this hex 38 offset, and then either looking at in the top 16 bits this additional 10 or this additional hex 14. I'm not familiar with that pattern, so I'm going to go back and see if this is used elsewhere. Create entity from entity is, or entity factory from entity, is used when weapons might have some like particle effect or other things like that, where those particles are going to be each their own entity. So let's see, we'll look in weapon to see if we find this elsewhere. Weapon 40 has... So it is doing something similar where it's doing the shift and mask. This likely is a pattern that should be pulled out. And maybe I'll look into that this afternoon. Actually, I'll look for this G-hand ID and see if that's happening. Okay, so there's a factory macro already for these. Let's look at that macro. We can find one of these that's using it and see how this works. So we're taking the first arg to the factory, shifting it by 8. So back to our code that we were working on. That's going to be, in this case, the first arg is going to be a 0 in this one, and 38 as the second arg. The hex A or 10 is going to be the first arg here, and 14 down here. And we can combine that with that shift to get the lower bits. No, we need to do the shift with the hand ID with the upper bits. So let's give that a shot. So we're gonna have a factory. Our first arg is going to be and so an intermediate value is screwed up somewhere. Oh, because we're already shifting over by 8 in the macro. So we need to subtract 8 from there. So we're going to shift by 4 instead. And that gives us yeah, so the way that the decompiler chose to offset by 12, we need to subtract the 8 there, and then we can fit it in. So we can do that with the rest of these as well. So we'll shift by 4. We'll add the we can still add the 10. Or not. This one can't be. How is this going to work? All right. Suggestion to go look at weapon 10. Got it. So the factory here, the hand ID bits are being separated from the factory bits, and that way we can have relatively consistent factory macro, all with the same hand ID function. I like that. I still screwed something up here. We'll go down and see what. Let's go back, actually. We'll go back to where we started. Oh, thank you. Oh, right. Because this is 16-bit shifted, not 8-bit shifted. That's where I'm screwing up. And then the same thing below. All right. So we have those working. We'll change this to the increment operator. And I'm just scanning through to see if there's anything else that will need to be changed. This will end up being the global animation set, which I don't have in my context. I don't really work on weapons off stream, so I never update my context. All right, so now I'm just reviewing again. So looking at the target versus the current, target's obviously the assembly that we're trying to get, and our current is over here. When we only have immediate values left, and those immediate values are offsets into structs, those are false positives that decomp.me doesn't necessarily know. In this case, we know this value is going to be set during link time, or I guess what is the phase of that, because it's not it's generated by assets as they're being pulled in. The symbol is mapped there. All right, we can change that to decimal. Again, thanks for the suggestion. Anything to reduce pain during a PR and get those in as quick as possible. And that looks like a match. So we're going to take this and go back to our project. This was weapon 53. Actually, before I do that, I'm going to do a few things here. I'm going to rename this to indicate that it was weapon 53, the entity weapon attack functions used in all of the weapons. And so when using decomp.me, it's nice to have a notation there to indicate what weapon it was, and I'm going to mark this as a match. Because the offsets are different, decomp.me won't automatically match it. So we'll go into weapon 53, replace the inline assembly with this implementation. I don't remember if I made this before checking out master, so I'm just going to clean and rebuild to make sure I have a clean project. This is going through and extracting all the assembly, all the assets from the original files from the PlayStation game disk, and then rebuilding, and then checking the objects that are being built versus hashes of those objects from the game disk, and all of those work correctly. Weapons are being built elsewhere. I'm not going to go through that though right now though. So I'm going to commit that. And then run make format. And there's probably a few things in here that I know the way I wrap functions is going to be different than the than Clang format wants to wrap them. So those probably got changed. Yep. And that was it. Amend that to the commit, and then we'll go to GitHub. Oh, drat. I pushed that. I didn't create another branch first. I don't want that in my master branch. So I am going to rename this branch. This is fun. Different Git operations. So I'm going to move master to W53. See weapon attack. Push that branch. I'm going to create a new master branch on in my local repo based on upstream master. I'm going to push that to my master branch as well. And now that shows up in GitHub. Do one last review. So I missed the draw mode here. That's why we review it again. So we can go back to decomp.me and fix the draw mode. I'm going to take this implementation and why can't I grab it? Come on, get up. I'm going to paste this back into decomp.me so that I don't lose the formatting. And fix the draw mode. So draw mode is 70. So that's going to be let's see, 40, 20, and 10. So it's going to be the same T page 2 and T page, but then one more. Unknown 40. That's being done down here as well. I usually switch these to line comments instead of block comments. Just a personal pet peeve. All right, and so we'll take that. I shouldn't say pet peeve, it's a preference. Entity weapon attack. Why do we have nothing here? Oh, because we're back on master. This will likely fail, this build. Oh, sorry, I'm working in the background. This will fail because the Dracula binary existed already, and check doesn't realize that it's in the process of being rebuilt. And so it's catches it in a race condition. When we build again, that'll be okay. We'll amend that commit and back up to GitHub. So this was a pretty fast one. If there's anything, after I'm done reviewing this, if there's anything anybody else wants to see or talk about regarding the project, codebase, or whatever, I am happy to take requests. Otherwise, I might spend some time mapping data, which is about as fun as it sounds, but it has to be done. So this looks fine. I'm going to submit this. We'll run through some automated checks, make sure formatting's fine, make sure that it builds with all the projects that build. It should only affect 2 of these. But we'll let that go. The other area that I've been spending my time is trying to get NO3 near complete. There's a lot of duplication in NO3. So some of this is low-hanging fruit to get this closer. So it's 89% of the functions are already decompiled. I believe there's maybe 15 that haven't been decompiled. 6 of them were really easy and had already been decompiled in other stages, and so I submitted those this morning. So those hopefully will bump this up by what, another 6% or so. But decompiling the stages isn't just about getting code in place, it's also looking at the data and getting the data mapping in place as well. So let me see if there's a good place to start with that. I'm going to check out master and see if we can get a clean project. So we have a clean starting point. So we can I'm going to check out the branch that I was working on. So when decompiling, splat is used to take the file that was on the game disk, so in this case stage NO3, and split it into different files and different groups of files based on offsets that are defined in this config. And this config is generated both through understanding the structure of the game, but also splat automation, as well as tools that are built specifically for Symphony and Night to find where these different sections are. When we see a data section, that is going to be data that was most likely originally defined as data in C, and it's mutable data that was loaded by this overlay, and then code can change those values. And we see other things like this RO data. RO data is immutable constants. The jump table that we had in the function earlier, things like that go into RO data. C files are, this is also the text section. This is code. And then BSS is also mutable variables, but it's mutable variables that were not initialized, so they have an initial value of 0. Historically, why that's a separate section, I don't really know. So I had gone through and mapped, for example, Bone Scimitar. I started that yesterday, or I talked about it yesterday a little bit in the stream. I realized what I had been missing was I pulled in this function, and so my offsets weren't correct anymore. And when offsets into a file, when you're recompiling it, aren't correct, you're going to generate a final binary that doesn't match. So we have RO data that's coming from jump tables in Bone Scimitar. Let's look at NO3 has a lot of similarities with NP3, and we can go here and see, do we have any obvious data that matches? So we have some initialization data at offset 500. That has not been mapped in either case. This is possibly able to be pulled into the header if it's possibly graphics banks. There's a bunch of initialization data. Again, that probably overlaps because we have a lot of the same entities. They're going to be initialized with similar data. It looks like this is about 80 some bytes in init, so that's pretty small. We can look at that. So both have this split for ST update, and they're both using likely the same implementations here. NO3 is not going to have Gaibon. I'm trying to see if there's anything. So entity relic orb, we don't have the data for. possibly MP3 doesn't have a relic. It does, and it's including the relic orb in miscellaneous. So maybe we'll split up miscellaneous in MP3. Actually, I'm not going to touch that because this might overlap with the PR Biz Murphy is working on. Let's look at the header, and we might be able to grab some of that data. So I'm going to start with the N03 header. So the header sets up the, in the PlayStation 1 version, the first several, the first data section at the front of the overlay file. When the Dracula program loads this overlay file, it loads it at a set address and then maps this first part of that set address into a structure that it then uses to interact with that stage. And so when it wants, when it's going through its own state machine, it wants to update that stage to update itself and all the entities that it holds, it'll call the update method. When it needs to do hit detection, it does all those things. So there is some abstraction between the main program and each of the stages, with some exceptions. There's some places where the Dracula program will check for what stage it's operating on and behave differently. But for the most part, this is the primary entry point into each of the stages. So we include layers. Which is a bunch of tile maps. And then our next section is this .5A4. So let's look and see what is in there. Yes, so these are graphics banks. There's several of them. They'll be listed in order, and then there will be a global here, and actually all of these are just graphics banks inlined. Graphics banks are so they're structures that have some data related to the graphics banks and then a pointer. And then they always end with a 32-bit value with all bits set. And then finally we have an array of a bunch of these. And the count of this array is the same as maybe this color lookup table. So we can pull this in. There may or may not be better ways to map data. My method of mapping data is to paste it and then kind of massage each of these into the types that they are. And we can look at another example where this is being done. A couple different places. are these not being... Alright, so I'd done this in the center stage. So when this is defined, we're looking for what the structure of each of those graphics banks is, and then reproducing that as C code. So we know what the binary values of a bunch of these things are. When Splat was extracting these, it didn't know what the data types were for each of these, so it treated them as 32-bit values. Because they're 32-bit values, but we want them as 8-bit values, the endianness switches. So these were, I believe MIPS is big endian. So the big side, or the high side is let's see. This value here for the byte ordering is the one that we're going to end up wanting, not the word value defined here. So for this first one, the first one is a special entry. We'll take that as it was. The graphics banks utilize a somewhat interesting feature of C compilers. I know GCC has it. I was actually surprised that GCC 2.6 already offered it, which is what this this project is using. What happened here? Which is having variable arrays at the end of structs. So effectively, we tell GCC that there's a field. The last field of a struct is a 0-length array. And then when we're defining that array, we can put as many entries into that as possible, or as we want. And the code needs to know how to determine how many entries there are. And in this case, what they do is they stick a 32-bit value in at the end, but each of the entries into this struct was originally 128 bits. So we can't just stick another entry in there. So we stick another variable at the end, which terminates this struct. And actually, I made a macro for padding, which creates a dynamic name, and we could probably do something here like that too, just a macro to say the graphics bank should be terminated. The reason I put this back is because the pointer, I wanted these I wanted this representation of these values to make them easier to split. But what ended up happening was then I want the symbol that was found. So different fields, I want different data here. Sorry, and I said they were 128-bit, they're 96-bit. Now we can get rid of this one. So this one is slightly different. Our kind is going to be, this one is a compressed graphics bank. We can find that by looking at, let's try game. And this is the 4th value, so maybe I did want those other ones after all. I'm going to grab the right one, in which case I should be able to say that this is 0, this is 1, so it's 40. And nope, I am not doing that correct. I need 16 bits for each. This is 1. We'll be able to see soon enough. Yeah, I'm happy to do this. I think anything to kind of show a software process, but also show how other people might be able to help is useful. I should write a search and replace for these, and I might do that. I'm going to go down to this one, and what I'd like to do is get to the point where this compiles, and then show if I did flip the byte ordering, there's going to be a difference between the compiled object and the one that we want, which is fine. But then how do we determine where that difference is? And I think that's kind of a useful skill to have when decompiling as well. You're going to screw up. Things are going to happen where you think a change is going to match, and then it doesn't. So I screw up on stream so everybody can learn. That's what I hope anyway. Okay, let's see if we can. All of these are going to be so what I was looking to do was find each of the labels here and generate the start and the end of each of these structures. And that'll allow me to get rid of the terminals. Open at the close. I'm not familiar with your username, your handle. Are you on the Discord as well? Are you somebody that I talk to frequently? So each of these has its prefix and suffix. So now I'm going to get rid of these, any of the lines that end in 4000 are going to be the kind. Biz Murphy. Nice to have you here. I know I have different handles as well on a lot of things. Streaming, I came up with this made up of wires. I go by Sulaco on most game services. I use my last name a lot of other places. So you gotta have a mapping of everybody's handles on different services. All right, so we have the kinds in place. Then I'm actually going to undo that one because I want to put the entries field in there as well. Because it will be, since I have this match, it'll be easier to find. Okay. So I didn't need the extra new line. All right, and finally, we have the graphics entries. So I'm going to look at the last word. So I'll do a star match, and I want then I want a new line. Just going to match across lines, and I want the same thing. I'm going to test this enough find before I I hate multi-line matches in Vim. Let's see if we can do this line by line. That is what I wanted. All right. So we're matching each of these. I actually want to split these up into 16-bit segments. So we're going to do 2 matches on these first ones. And then our graphics bank is going to be, our graphics entry is going to be a so we'll try this. Oh. Why did this one feel? Oh, I missed the. There we go. So I'm just going through and tweaking my substitution. Trying to get something that will get me most of the way there. And that looks better. I missed the trailing comma. And I'm indented one too many. Stuff like this I usually do more manually. I feel like in the time that it takes me to write substitution, sometimes I can just bang out the changes manually. I'm missing a trailing closing bracket on all of these, which I'll just put in manually. I'm also missing 4 declarations for the pointers in each of these. So I have to pull those out and add those. My CD is skipping something terrible, which is a bummer because I try to take good care of those things. I didn't see anything on it that was particularly egregious either, but I noticed that yesterday too. This is also one of those areas where graphics entries is going to be in a lot of stages, a lot of places. This is very mechanical. Should I have just sat down and written a script to do this? Probably. Or added it to one of the existing tools. There's nothing interesting about this. Oh, they just keep coming. The end will be worth it, though, I think. So, assuming that I didn't screw up any of the sizes of anything, this should slot right into place where that data entry was. I'm not expecting this to match right away. Likely I have the byte ordering wrong. I am going to compile this. It's going to fail, partially because of I'm going to have duplicated symbols, because Splat is going to be compiling this, but it's also going to be pulling the data from the assembly file. Right now, though, I mostly want to see if I screwed anything up in this file. Okay, I did. So it's upset that one of these. Oh, these are supposed to be pointers. That was a simple one. 38. These are pointers. I don't know how many of you program in modern programming languages primarily, but switching between languages that have and don't have semicolons, I always leave them off when I'm back in C. Okay, so the compiler error was about entity merman. That's because of this branch. I've shifted those things around. So it's no longer at this 516b4 location, and it's not going to be able to find it. So I need to clean. Actually, before I do that, I'm going to go to the Splat config for NO3. And this data now is part of the header. It's no longer its own thing. In some cases, so having this entry here and adding, marking that this is header and saying that it's the graphics banks works. That would make it easier to split graphics banks out later. So I'll leave it like that. So I'm going to clean and re-extract everything so that things get put in the right place. And I'm going to run it again. I still am not sure about that byte ordering, so I'm not expecting it to match. If it matches, that's great, but if it doesn't, I'm not very concerned either. I've mentioned on the stream before, yeah, it failed. If I can brute force my way through a problem, often I'll do that as opposed to going back to the docs, seeing what the correct byte ordering for each of these things should be, what the types were. It's much easier for me to look at what I did wrong and then fix it, and learn along the way. Oops. So there is a tool in the repo for doing diffs against objects. I've actually not used it. I wrote this before I knew that tool existed, which just goes through stages and does a hex dump on the good stage and the one that was built, and then does a diff against those. It would be nice if I forced color all the time, so I can run it through less. So when the difference is in assembly, and you're trying to figure out, is my instruction wrong? Is my immediate value wrong? Typically that's going to be in the first byte or 16 bits. of the instruction to tell you that. And the data portion of that instruction is going to be in the second half of that. In this case, we're dealing with data, and so all of it's just bytes, and we can look at that. So in the original, we'll start with that first line. So we have our 4, which is fine. And then on this last 16-bit value, both of these are swapped. So we can go fix that. I'm going to just pull ahead of that. So this is going to end up being hex 100 and then hex 40. And likewise, these are going to both be 80, and these as well. So now when we build, that one should be fixed up, and when we look, our diff is much closer. And so we'll go through and clean all those up. Again, should I do a find and replace for these? Yes, I should. That's what the good engineer would do. So I'm going to look for, I might screw up those top ones in the process, but that's okay. I'm going to look for 4-digit hex values. Actually, only these later ones will be 4-digit. I don't know if you if you can hear the music on stream. This is from Nier Automata. Those are excellent games. All the Nier games are excellent. And usually the soundtracks are epic and grand. But there's nice playful things in there as well. Still failing, that's okay. Look again. Oh, we're worse. We're worse. So the next thing that's useful to be able to do is look at an offset in a diff and say, okay, my error is at 5D0. I can look at splat and say, okay, it's somewhere between the header and this layout, but where is my difference? I like to often make notes for myself in comments about what the sizes and offsets of things are when things are in flight, but there's maps that get built by the compiler that will have all of that information as well. So we're going to be looking for 5d0, y. Oh, it won't be OX 5d0. And of course, they have nothing in here is getting pulled out because everything is static to that file. So we don't have symbols that are getting pulled out in the process. So in this case, the map is not going to be useful to us. It is telling us though that our header is going all the way to 77C, and so we can confirm that yes, 77C is where the where this should be, which is useful. So we can look at the names as well. The names that are automatically given to variables are their address. And so we can look for 5d0 here. Our error probably is not at 5d0, but at 5d8. Which is here. Did my replace not find these? Did. So the second value, the second and third value look like they were encoded as a these ended up getting flipped. So it was a 16-bit value, but they're split apart into two 8-bit values. So when we do the replacement, we have to be aware of that. Okay, we'll undo it and do it again. So we split it. We're going to be taking try this 6, 5, 4, 3. Any closer? Nope, that was worse. Flip the wrong ones. That's looking better. And then we have the wrong ordering. further down though. 5e, so this is this fourth value. These are our last two 16-bit values. There we go. Finally got the byte ordering correct. Okay, so we have the data mapped and the byte ordering is correct. And so when we build now, this NO3 data is matching. Our splat config points to the header, saying that the data is there. And now these are known C types. Most of these variables are static to this file, which means if you wanted to compile this, say, for another platform, this should be, hopefully, this portion of NO3 should now be portable. Neat. Okay. So that's data. Not as fun, to me anyway, not as fun as decompiling code, but just as necessary. Thanks. Oh, I need my emote to make myself there we go. All right. Let's see. I'm going to go back. I have this branch in the middle of PR already. If nobody's looked at it, I will probably sneak this in, but it looks like... Oh, the only comment is mine. I'm going to sneak this into this PR. All right. Now I recognize you. All right. Well, that's it. This is about 20 minutes over the time I like to give myself each day for streaming. What did I miss these? Oh, I formatted, of course. Format first. So we have we decompiled a entity weapon attack function for weapons with a jump table. It turned out to be an easy one. That's great. wasn't any more challenging. Just needed to make sure that the jump table data was there when we decompiled it, and then decomp.me will take care of most of it. And then looked at some data, how to take data from a file that Splat has extracted, migrate it to C, and then deal with some of the differences in byte ordering between the assembly, the C, and what those fields might end up being. And that's it. Definitely thanks for the comments. If there's other things people want to see, I'm trying to be consistent about kind of going over the same process each stream, just to kind of drive home that it is a process. It is something that you can learn and just follow some simple steps. You don't have to be, an assembly programmer to do it. You don't need to, if you can do data mapping, you don't need to even be a C programmer necessarily to do it. It really is something that I think a lot more people could help with, and I'm happy to help push people in that way. If you don't want to help with Symphony of the Night, there's lots of other decomp projects that could definitely use a hand as well. And decompiling anything for any platform is going to help basically the entire decompiling community as people learn things along the way. If you want to know more about the Castlevania Symphony of the Night Decomp project, you can go to sotin.z.dev, where you can see progress of the current objects that are being decompiled for the PlayStation, as well as I think some of the PSP stuff is down at the bottom. You can join the Discord, SOTN Decomp Discord. There's a lot of stuff going on in the Long Library Discord as well, with the randomizer and other ways to mod and hack on Symphony of the Night. If you have suggestions, areas that you're interested in looking at, I'm happy to go over those as well. So please feel free to chat and send any of those ideas. Otherwise, that is it. And if you want to see more, I'll be here on Wednesday and Thursday as well, and then ongoing. So follow, subscribe. I post the replays on YouTube, and usually I'll publish them to Twitch as well if there's something that you missed earlier. All right. Thanks, everyone.